Hello, YouTubers. This is a new session where we get to continue our journey into architecting solid, reliable AI solutions. In the last session, we talked a little bit about how you can reliably teach your LLM about one MCP server function. And the function did add a couple of numbers, and you basically sent a prompt, and the LLM understood that this is a function that it needs to call, and it called the right function after we did a JSON serialization, and it did the right trick. Just a kind of quick reminder, kind of on our previous episode here, I basically went ahead and we pointed it to a Mistral Instruct 7 billion parameter. We told it, give me the outcome of 22 added to 55. It went ahead and basically, like originally, we basically told the large language model system chat is that, hey, you are an assistant that always responds with the following JSON format, right? And outside of this JSON format, you can only respond with this particular serialization mechanism. So don't respond in anything other than this particular format. And we basically just went ahead and said, hey, this is reliable. We think it's reliable. Give me the outcome of this plus that, assuming that the model have responded with the JSON that we expect. We extracted that JSON here and we serialized it based on this MCP root model, and we basically just continued from there. If this is true, so I restarted my machine, I reset everything. If this is true, if I run this again, it should still work the same way it's expected to work. Let's take a look. There you go, MCP function. It's still beautiful. Even 6 days later, you could reliably actually trust this thing that it's going to do the right thing. It's going to hallucinate a little, but it's okay. It's a router. We just want it to respond with the right thing. All right, let's make it up. And by the way, just so you know, like one big thing that we said, extract the first JSON object, because we know that there's hallucination. We know that it's gonna, do some crazy things. So we said, hey, just give me the first JSON object. So let it go crazy for a while. Ideally, our outcome would be 22 added to 55, which would give us 77. Let's see if that still works. There you go. MCP server response is 77, right? But the world is not like that. You're architecting an AI solution, right? So it's not always going to be one function that you pass to the system and expect it. But also, like, even more importantly, we told it, hey, when you are asked to add two numbers, go ahead and put the function name, first number, second number. All of this is hard coded. That doesn't work out, right? Because you want your LLM integration with the MCP server to be dynamic, right? So whenever the MCP server is adding new functions, new capabilities, maybe today it's offering you the weather forecast, maybe tomorrow it's going to tell you the latest news, maybe the day after it's going to tell you the stock market. You don't want to go and rewire and hard code that. That's just not good architecture. So what can we do today? Remember, this is a user, and this user has a prompt, and the prompt will go to the LLM like that, LLM, and then the LLM, that's what we built last time, right? And the LLM will talk to an MCP server, or MCP function, let's just see MCP function, and we hardwired it to talk to this MCP function, which is the add, okay? Which is okay for a quick, fun YouTube demo, but I want to give you the enterprise version of this. So instead of doing that, instead of hard coding it like this, I want it to actually talk to the entirety of the MCP server, which may have multiple functions. And that's your MCP server. And there's an exchange of information here that I'm going to show you, MCP server. So what is the exchange of information here? The first exchange is that the LLM is going to hit the MCP server first, right? And the MCP server is supposed to give you back something called the catalog. The catalog is basically, this catalog is basically the set of functions and parameters and what every function does on that server. So you basically want the function to literally say, or the server to literally say, hey, here's all the things that I can do, and I'll let you kind of decide on your own. That's the intelligence part of it, to go and tell me whether this is needed or not, right? Or whether you need that function or not, or whether this function is useful or not. Okay, so there's the catalog, and then after the catalog, we send in the function call. So this is going from here to here. Let me just kind of visualize this for you. The function call will go to the MCP server, but the MCP server first is going to tell us, I mean, upon our call to it, it's going to tell us what are all the function that it has. So it needs to tell us about, let's say for example, the addition function, and it's going to tell us about the subtraction function, and it's going to tell us about, I don't know, division function, and so on and so forth. Okay, you get the idea. So that means whatever that server may be, it could be a server that you developed or a server someone else developed. It doesn't matter, because the LLM will learn what it can do and then use what it could to kind of leverage that server. So let's take a look what that looks like. Well, let's start with something simple then. Let's go into our simple project here. Of course, the source code is the source code. You're going to find it. Let's just go to the server here first. Before I forget, I'm going to make this disposable. My dear friend Brian Parker here told me that, hey, instead of kind of trying to shut down the server using uh, PowerShell, why don't you just implement dispose? So I'm just going to implement dispose here and just kind of do that so I don't have to shut down the server manually. But I'm going to go and add a new function in here. Let's just add a new function, and let's call this function subtraction. Watch this, subtraction. Okay, so this is subtraction. Okay, we'll subtract. Let's call this a function. This function will subtract two numbers. This function will add two numbers. First number, second number. The only difference is that it's actually just doing subtraction. Okay, so I added another function. So now this whole idea of going here and saying, oh, there's addition and there's subtraction is not going to work anymore. It doesn't scale, right? It's a problem. So let's just first build the server, and let's see the MCP server. Still the last instance that I started. Okay, fine. That's oh, not this one. Not this one. Hold on. Uh, let's see here. Yeah, of course. So I did the I did the command, but before I get process, stop process. There you go. So now if I build this guy. Okay, now it's built. So now we know that we have a subtraction and addition function. So how do we know that, right? If you look at your client in here, this same client that we have, if I go at the very top here and basically go and say, okay, this is your LLM chat, all of that, where is my client here? It's right there, MCP client. Let's raise that client up a little bit because it's going to be part um, of our prompt. So we need to know about this client before. I'm going to do var functions in here, and I'm going to go and say await client.get functions async. This guy alone is going to give you all the details you need about that particular MCP server. This is all running local. It's all yours. So if I put a breakpoint here just to show you and run this client, watch this. Look at these functions. If I go and basically do a quick watch, guess what? You have two functions in here, right? One of them in here, the function will add two numbers, and this function will subtract numbers, and this is, and you think about it, right? You can add as many as you want. Okay, so that's one piece. That's great. So I know about the functions, but that's not enough. I need to teach the system, right, that after it knows about the functions, to build a catalog of these functions. Let's build a catalog together. Very slowly and surely. Here's catalog equals new. I'm gonna make it a dynamic here just because I didn't build the model for it, but you can build the model however you want. So this is a catalog new. So I'm building this catalog, and then inside the catalog, I'm basically saying you have a list of functions, and these functions are like this function new, and I'm breaking every function here into a new object. Basically, the function.name and the schema of that function. And that's the function dot JSON schema, just like that. So this is giving you the JSON schema for this function. The output of this is what we're going to feed your LLM model, right, to teach it about what's going on with your function. So let's just serialize this. We need it in a stringified format. So I'll go here and say var JSON options, new JSON serializer options. Okay, I want the indentation here, so right indented. This is me saying make sure that the indentation happen. And then here is your function catalog like this. And this is basically JSON serializer like this, right? And then serialize, and then the catalog with the JSON options like that. Okay, serialize. JSON serializer, serialize. I bet you it pulled, yeah, newtonsoft.json. That's why. There you go. Serialize. Just like that. Okay, so let's see what that looks like now. So if I run this again, I hope I forgot something. Hold on. So, yes, JSON serializer, because the old one was using um, the old one. Okay, yeah, the old attempt that we did was using the Newtonsoft, but I'm gonna switch to system.txt, which is this guy, system.txt.json. I'll tell you why in a second. Okay, so let's look at this function dialog right now. Look at how beautiful this is. I basically built this here to give you a catalog that has functions. It's an array of functions, and every function has the name, the schema, and it'll tell you the first name, first number, second number, and so on and so forth, right? We'll play around with this a little, but this is basically what this catalog does. It basically teaches in a very stringified format, right, about the situation that's going on with this. Okay, now let's take this guy and create something called user prompt, because we're gonna add into that user prompt in a second. So this is a user prompt. Give me the outcome of 22 added, and this is intentionally written this way just so I can show you, how smart this thing is and what I can do. Okay, we'll get to that part in a second. Let's just go to the part where we add the prompt. Now watch, this is where it gets interesting. In here, I'm gonna tell it, here's the catalog, here's the JSON request. So this is here is the catalog like that, and that's my catalog. We already built that guy. So if I put a $sign here, I think, and then I go and say function catalog, and then I'm gonna go here and say user prompt or user request like this, and this is where I'm gonna put the user prompt like that. Now watch what I'm doing at the end. I'm basically saying respond with JSON only. Respond with JSON only. Don't respond with anything else on top of that. So pay very close attention to this piece. I'm basically saying here's the catalog and here's the user prompt. Begin the output with this, with the open squiggly brackets, and close with this. Now I have all this together, that prompt that contains everything together. I can pass this down to my send async kind of dealio, right? So I'm basically really playing the strict game, but I'm making it super dynamic. It's still gonna map down to my MCP kind of model that I built for it, and you can map it to anything you want. It's your own LLM, right? But you're gonna have to make sure that you pull in the existing schema and build on top of that. Okay, so far so good. Is that enough? No, not really. We need to change this guy. This guy was very hard-coded towards a particular a function. I'm gonna change it into this one powerful, super powerful prompt in here. There you go. Let's just go through this prompt. You are a function router. Use only the functions and parameters listed in the catalog. Task, pick exactly one function that best matches the user request. Produce parameter values from the request. Output constraints. Output only a single JSON object. Do not echo the catalog or any pros. JSON shape. Here's the shape that I expect you to produce the JSON in. It's very strict about, kind of all the parameters that you're gonna get through. And here's a bunch of rules, right? Only the parameters. If required parameter value is missing, set value to null. Parse numbers, booleans from text. It really went through the whole, like I told you, prompt engineering is a whole world. It's a whole new science that you're gonna have to kind of be able to hone it down to be able to kind of interact with LLMs. Now, moment of truth. Does this thing actually work? Let's find out. So I'm going to take the breakpoint here and I'm going to go all the way. Actually, nothing. I'm just going to let everything just work as is. Let's just run the system and see what happens. Here we go. This is supposed to call the addition function, but let's just see. It's taking a second there. Here we go. Good start. Name addition. Ah, beautiful. Look at that. First number, value 55, value 22. Here we go. Here we go. 77. Amazing. Amazing, right? It's the exact same thing. I took out all the stuff that are hard coded for the addition function and I'm telling it interact dynamically with the server, right? Now, let's play around with it a little bit. So I'm going to go here and say, well, my original prompt was about addition. Let me send you, instead of give me the outcome of 22 added to 55, taken out of 55. So I'm saying give me the outcome of 22 taken out of 55. So it should give you 33, right? Let's see. Is it going to determine based on that this is an actual subtraction? Is it going to subtract the value? Let's see. Here we go. Okay. Look at that. Subtraction. Look at that. 22, first number, name, second number, value 55. Just pure art. Look at that. 33. And you know what's crazy about this? What did I add? Did I add to it's even smarter than me. Look at this. I did say, look, it says minus 33 because I said 22 taken out of 55. So the language model put it in an equation and said then you end up with minus because you did 22 minus 55. Amazing, right? What if I made this in pure format, like what do we get when we add 5? So I'm writing down the letters 5 to 15, right? I'm even gonna intentionally make a typo. So instead of 15 like this, I'm gonna make it like this, 15, to see if it can pick up my mistakes and actually fix it. Let's see. If you want to see LLMs in action in a reliable way, this is it. This is your go-to right there. Let's just see if it works. Here we go. MCP function addition. Okay, that's good, I think. First number, value 5. Second number, value 15. Oh my God, look at that. It's gonna hallucinate for a while, but it's eventually gonna come to the end. So I did say add 5 to 15, yeah. So that first JSON is exactly what you're looking for. It's going crazy right now because look, 15 and 5 and then 5 and 15. There you go, 20. So it actually, despite the fact that I had a typo, despite the fact that I wrote it in raw text, it still figured out what to do, which is amazing, right? Let's mess with it even further. right? Let's play around with it even further because I love this, right? Let's just say that the subtraction function will subtract three numbers. So I'm going to add another layer here. I'm going to call this your second number, and I'm going to call this your third number, like this, just to show you that this is actually third number. This is actually dynamic, right? And this is your second number, third number. So subtraction now only subtracts three numbers, not just two. So it's different. The model sort of different because the number of parameters here are changing, right? Let's see what that does. So first number minus second number minus third number. Okay, I get it. Now let's see if it will let us build though. Did this dispose thing work? I don't think that dispose thing worked. Well, Parker, dispose thing didn't work. So okay, so I killed the process, and then I'm gonna go to my client here, and then I'm gonna go and say, what do we get when we subtract 5 from 10 from 20? I'm gonna even like play, I'm gonna be really a jerk here. I'm gonna just flip from numbers to letters, and so 5 from 10, that's 5, and then from 20, that's minus 15. Let's see if it can figure that out. Here we go. This is the real challenge. Please try this at home. Zooming in a little bit for the people on their phones just to get they can see. Here we go. Subtraction, correct parameters. Mm-hmm. Mm-hmm. Oh my God. Look at that. Right? Amazing. This is amazing, right? I said 10 when we subtract 5 from 10 from 20, right? So 5 from 10, that's 5. It didn't really honor the order, which is okay. I'm not super happy about that, but that still kind of came through with the results that I expected, which is just quite phenomenal. That's amazing, right? Let's run it one more time, just for funsies, and see maybe it will honor the order. I think we have to prompt it to tell it exactly honor the exact order of numbers, but I guess in this case it doesn't really matter. Let's take a look and see. So what this is visualizing is that it doesn't matter. You could change your model, you could change your input parameters, you could think about different solutions. It doesn't matter. Look at this. Look, I know it's hallucinating, but the prompt is so strong that it's not letting it play around. Look, second number, 5. Did it still do? Ah, interesting. I don't know why it was doing that. Why it's not honoring the order even though the result is still right there. Okay, hallucinate for a while. It's even explaining to you what it's thinking, which is crazy. Mistral is just a blessing. It's amazing. Okay, there you go, minus 15. It did even explain its like train of thought. The user requested the result, the catalog contains, the addition function requires two numbers, but subtraction requires three numbers. Since the user requested subtraction, blah 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 blah, and it amazing. I'm not even gonna say anything beyond this point. I'm just gonna go here and say, here's let me do this, and I'm just gonna go here and say, MCP feature dynamic MCP functions integration. That's all I got for you today. Um, this is it. This is the deal, right? Your MCP server is now, or your LLM now is so smart, it can basically just learn from your MCP server what it needs, and then based on your prompt, it will take that and crush that, and then go and take the response from the server and come back and basically respond with that particular value. I hope you find this a little bit useful. There's still more into AI architecture that we need to talk about. Like right now, we're basically using LLMs as a really, really, really smart natural language processor, right? Because it's taking the input and it's processing it and then it's calling a function. But we want it to also respond with that. We want to respond with that. And there's even more deeper kind of levels where we go and say, well, what if my request had both subtraction and addition, right? So you want your LLM to be smart enough to break down the prompt into multiple tasks, if you may, and go full agentic on this, right? Break it down into tasks, find the right tools, and scale up. AI architecture is amazing and beautiful, but it's also infinite. Like there's an infinite number of things that you can do. I can't wait to share all that stuff with you. I hope you find this a little bit useful. As usual, if you have any questions, comments, concerns, please feel free to drop a comment in the comment section. Don't forget to like and subscribe. Code will be in the description. Take care. Happy learning.